Hey guys, so good morning or good afternoon, depending on where you are in the world. My name's Omar Zoni, and I work for Solidworks at Dassault Systems, and I am one of our simulation specialists. So, in the next hour, we're going to be talking about some really cool stuff that's going on here at Dassault Systems, specifically related to the simulation space. So, let me give you a little bit of background. This is my first time using OBS, which is the kind of the program that's being run to host this thing on YouTube. So if I make any mistakes, I apologize in advance. It's very likely that I will. If you guys catch me looking off to the left, it's actually because the chat window's over there. I'm not ignoring you guys or gazing out into space. It's just I want to make sure that things are going all right. So let's go ahead and get started. And I'm going to preface this by saying I do not intend to spend a lot of time in PowerPoint, but I do want to give you guys a little bit of background because, like I said, there are a lot of moving parts and a lot of things that are changing right now inside of Dassault, specifically related to how the brands kind of work together. So what we're going to be talking about today is specifically Simula and which is a small part of the whole 3D Experience Works portfolio, and how you can actually use 3D Experience Works tools to kind of expand and extend your simulation capabilities. So I know you guys know SolidWorks. SolidWorks is one of the brands that resides in Dassault. And we absolutely adore working for SolidWorks. Our user community is so passionate. You guys are kind of the lifeblood that keeps us going. And but that is just one of the brands that's available inside of Dassault Systems. So I want to talk to you a little bit today about the SimuliaWorks portfolio, what we've got right now. I'm going to explain what SimuliaWorks is. I'm going to give you guys a demo of kind of moving from SolidWorks into the platform and using SimuliaWorks. And then I'm going to show you guys some more really, really cutting edge types of analyses that you can run now that you really probably couldn't have run in the past, specifically related to like explicit dynamics. So again, SolidWorks is one of the brands that resides inside of Dassault Systems. Another brand that resides at Dassault is a brand called Simula, and kind of I would argue the flagship product for Simula is the Abaqus solver. Now, Simula is actually responsible for the development of all of the simulation capabilities inside Dassault. So even if you're using SolidWorks and doing desktop simulation using, SimExpress or SimStandard, SimPro or SimPremium, those tools are all developed by Simula. It's a very powerful brand. And I'm showing you this slide because I want you guys to be aware that the commitment that Dassault has to simulation and simulation capabilities is very, very deep. So these are the acquisitions basically that Dassault has made in the last 20 years. Again, they all fall under the Simula umbrella. So when you hear the word SimuliaWorks, what it is, it's a collaboration between the Simula brand and the SolidWorks brand on the 3D Experience platform. And we'll talk a little bit more about what that means. Now, I know I've worked for SolidWorks for 10 years. We're and in the simulation space at SolidWorks, we're very passionate about what the desktop tools can do. But we need to be honest, right? There are points where the desktop simulation tools hit their limits. There are also certain types of physics that we couldn't solve using the desktop tools, right? So acoustics, electromagnetics, Tosca and optimization has kind of worked its way into desktop a bit. But we really don't have a great durability solution. So within Simula, they have the building blocks for a complete simulation suite. So shame on us, for not working with them sooner, right? This is a collaboration between these two powerful brands at Dassault that makes so much sense. So what we've done is we're starting on the structural side and working. So the tools that we're going to talk about mostly today are going to be related to the Abaqus solver. Let me just make sure I'm not making any mistakes. All right, I don't think so. So we've kind of historically broken up people that use simulation tools into three buckets. There's designers, there's engineers, and there's analysts. On the left side, you've kind of got people who spend most of their time in CAD. On the right side, you've got people who are spending all of their time doing analysis. And then, there are simulation solutions that are available from us that kind of break off, across the spectrum. So what we realized a couple years ago is that simulation premium on the desktop kind of hit its limits, And it didn't make sense to continue to develop the nonlinear solver when we have such a powerful tool in our portfolio with Abaqus. So SimuliaWorks is again, it's a collaboration between SolidWorks and SimuliaWorks. It's pulling a lot of the capabilities from Abaqus, and it's got a much more intuitive, user-friendly interface on the 3D Experience platform. So we're kind of stepping up from Sim Premium. There are some capabilities that Abaqus has that we still don't have for SimuliaWorks, so it's really customized to the capabilities and types of analyses that we feel like our user community is interested in. So there are three kind of products available right now. These are let me talk a little bit about the 3D Experience platform. The 3D Experience platform is a collaborative environment where all of the tools that Dassault has acquired or developed are being integrated into that platform. So when you see these roles, these are basically roles on the platform. And these three roles are what we're going to be talking about today. Simulation Collaborator really isn't a simulation role. It's more for you to review and compare results. So I am going to start in Structural Designer and show you guys how you can take a model from SolidWorks and do some basic analysis. Now, there's also Structural Performance Engineer, which turns on nonlinear capabilities. It can do implicit dynamics. It's got very, very complex materials. We're going to talk about that also. And then Structural Mechanics Engineer is basically turns on the Abaqus Explicit solver, as well as a material calibration app that's really powerful if you've got material test data and you want to fit it to a material model. So this is kind of a little background about Structural Designer. It's using the Abaqus solver, but it's a much more guided workflow. So it's really meant for people that don't spend a lot of their time doing simulation. So let me pop out a PowerPoint and go. Let's start with SolidWorks. So, and I apologize, guys. I just need to refit this so that it fits in the screen adequately. All right, that should be close enough. So recently we were contacted by a beverage manufacturer. So I'm going to spend a little bit of time working in this model. And they had some industrial designers that they wanted to be able to do some kind of first level. Actually, because some of the analysis they wanted to do, I wouldn't consider first level. It was pretty advanced. So but they wanted their industrial designers to be able to run a handful of tests. So like a crush test, a drop test, and then some pressure tests. So we mocked up a model, and I'm going to kind of walk through exactly how we can run some of these analysis using SimuliaWorks. So there are a couple ways that you can get your SolidWorks models into the platform. We've got a PLM strategy, which allows you which provides a little bit of revision control, right? So if you want to ensure that changes that you make on your SolidWorks model are going to be accurately controlled and pushed to the platform when appropriate, there's a PLM strategy. The approach I'm going to use, just because this conversation specifically for the next hour is not really meant to cover PLM strategy, is I'm just going to directly import the model into the platform. So you guys can see this is my SolidWorks assembly. I'm just going to close SolidWorks, and the rest of the time we're going to spend here in the platform. And this is a model that we'll talk about a little bit later. So what I'm going to do is I'm just going to directly import my SolidWorks model. Now, whether you're using the PLM strategy or you're just directly importing a SolidWorks model, you still have the platform still recognizes if you made any changes. So let me go ahead and just import. And there are a whole host of formats that the platform can read in, from neutral formats to to SolidWorks. So there's obviously STEP, there's IGES. I am just going to ask us to read in a SolidWorks assembly, and I'm going to point to that bottle that we just had up. Now, so this will take a minute. It's going to go ahead, or a couple seconds. It's going to go ahead and import my assembly, and depending on the number of parts, this could take a little bit of time. This is a relatively simple part, so it shouldn't take too long. Now, I am kind of a nerd, so I'm going to show you guys something here. Depending on the apps and the roles that you have, that kind of dictates where the product's going to be read into. So if you come over, you guys can see I have like every role turned on. I like to, so it can be a little bit messy. Obviously, for most companies, you're not going to have all of those roles turned on. So recently, I was playing around in function a generative design tool that's available on the platform. But what I'm going to do is I'm going to take this model now that it's on the platform, and I'm going to say that I want to open it using Structural Designer. So again, I'll just highlight my structural designer role. These are the apps that are available inside that role. And I'm just going to say, look, I want to do a linear structural validation. And it knows that whatever part that whatever model that you're on in the active window is where you want to, is the part that you're going to want to run the analysis on. So again, it's a guided workflow. It's asking me here, like, what kind of analysis do you want to run? So let's say that I want to start by doing a structural analysis just of the bottle. So I'm going to tell it. Now, again, this is the low-end tool. Don't be confused. It's still using Abaqus technology, but this is really meant to be for people who are, they spend most of their time in CAD. They're not analysts. So it's got a very guided workflow. Don't lose hope. I'm going to show you guys some way more complex examples as we move on. But I wanted to show you kind of something from soup to nuts so you guys could get a feel for exactly, what the workflow feels like. So in this case, instead of using all three parts, I'm going to say that I just want to include the bottle. So I'm going to get rid of kind of the top and the bottom. Just going to use the bottle. Obviously, the first thing that I'm going to want to do is specify the material, right? So there's a nice material palette that houses all of your material data. So I'm going to make the assumption that this is like an ABS plastic or something. So there are some predefined materials that come with the software that you have access to. Obviously, this is just like SolidWorks, right? So if you're running analysis, oftentimes customers are going to want to have good control over their material property data. So obviously, you can create your own material properties and house them where you'd like on the platform and make sure that you have good material property control. So I'm just going to grab one of these ABS materials. Gonna drag it over onto the bottle because I'm going to make the assumption that this bottle is made of ABS, and I'm just going to go ahead and confirm that. Now, again, this is meant to be a super easy workflow. With respect to the mesh, I'm just going to specify a global mesh density. Let's say that I want it to be 15 millimeters. You do have the ability to create some local mesh controls. So if there are certain areas where you want to have a tighter mesh or a better mesh, you can certainly do that. So very quickly, it creates the mesh. I'm just going to apply a basic restraint on the bottom. So I'm going to say that this bottom face is clamped. And with respect to loads, I will just say that I want to apply a force to this top face. You can see the arrow kind of dictates the direction of the force. You can, rotate that arrow. You can orient it with an axis. You've got full control over the direction of our forces, pressures, any kind of loads, right? So, and I'll just put a 5 Newton force in the down direction. Now, one of the real powerful things about these Simula tools is that you can actually run these on the cloud. Now, for a linear analysis, probably not as important, but you do have the ability to run on the cloud and utilizing credits or tokens. Or I'm sorry, we just credits right now, but we're going to have a simulation kind of token if you want to run it, utilizing more than 4 cores, which come out of the box. So when you buy this software, you can run on 4 cores. So I'm going to run it local, just on my local machine, and turn it all the way up. Oops. And within, a couple seconds here, we're going to have some preliminary results. Now, again, if you wanted to go back into SolidWorks, modify your part thickness, or make any changes to the bottle itself, you could certainly do that. And there's a SolidWorks update button that is available to that allows you to update your geometry kind of in real time. So while this guy is running real quickly, I'm just going to pop over here and take a look at some of the, if there's any questions. The simulations are made in the cloud. And it looks like we'll get to answering some of these questions, but let me just keep moving. So you guys can see the simulation's completed. It runs relatively quickly. You've got basic results that you can take a look at now. So reaction forces, displacements. Obviously, you can do cut plots to take a look at what's going on internally. With respect to post-processing, you've got kind of the full range of things that you can look at. So again, not necessarily with this tool because this is just kind of meant to be a first pass kind of analysis, but you've got vectors, reaction forces, whether or not you're in compression or tension. So a really powerful kind of first pass tool, and this was just a structural analysis. But if one of the things that was of interest to this beverage company was also buckling. So you could also do a first pass buckling analysis. So I'm going to go back to my geometry and do the same thing that I did before, right? Let's just say I want to run a linear structural validation, but instead of doing structural analysis, I'm going to do a buckling analysis. Steps are kind of the same, so I can specify the contributing parts that I want to include, which is just going to be the bottle. I'll use kind of maybe a little bit more coarse of a mesh. Let me specify my material. So for this one, let's we'll use ABS again. But I mean, you've got a whole host of material properties that are available, so just be aware of that. And we also, so the reason why you see all of these plastics, there's also a really cool injection molding tool that's available on the platform. So I'll show you guys a little bit about what's coming next and what we see in the future for Simula. But there's a flow tool that is actually available right now, and there's also a plastic injection molding tool that's available. So again, I'm just going to use ABS again. And similar setup, right? So I'm just going to restrain it at the bottom. And I will, with linear or with buckling analysis, right, you kind of apply a dummy load. So I'll apply a 1 Newton load. And then what it actually solves for is what the buckling loads would be. So let's go ahead and run this guy. Now all of your data is stored on the cloud, so you don't have to worry about like where your data is going to reside. And again, if you wanted more control, you could certainly utilize that PLM strategy to ensure that you're modeling and simulating the correct products with the correct design changes. So we'll let this guy run real quickly, take a look at the buckling loads, and then I want to move to some much more advanced types of analyses that you can run with this software, right? So again, Structural Designer is just meant to be for people who are doing kind of linear first pass types of analyses. The stuff we're going to show next is much more advanced, and I'm really going to point out some of the compelling things that Simula and Simula do with respect to simulation that maybe some other products, certainly not our desktop product, don't behave that way. So you can take a look at the buckling loads. Let's see, there's some much more interesting ones, right? So again, remember, if you're running a linear buckling analysis, you typically enter in like a 1 Newton or a 1 pound force load, and then the value you get is scaled to that, right? So the reason why you use 1 is 1 times a number is a very easy calculation to make. If you use 3 or 4, some other random number for your load, you just have to take that number and multiply it by whatever the scaling factor is here. So you get a feel for what the buckled shape is going to be and what those buckling loads are. All right, so now let's start talking about some of the more advanced things that you can do with this product. So I mentioned there are kind of three simulation packages that are available. There's Structural Designer, which we just talked about. There's Structural Performance Engineer. And then there's Structural Mechanics Engineer, and Structural Mechanics Engineer really turns on explicit analysis. So what I want to do is I want to take a look at this model. So this is a relatively simple looking gear assembly, right? Just two gears. The intent here is to apply a rotation to the bottom gear and get a feel for how much torque is required to rotate this assembly. But what you'll notice, first of all, is there's a bit of interference between the gear teeth and its initial resting position, right? So what I would like to do is initially I would like to resolve that interference and then rotate this. Now if you were running this with the desktop tool, right, you would have to identify the contact pairs. So what faces are going to be coming into and out of contact, right? Well, the way Simula handles contact is completely different. So rather than making the assumption that faces that are touching are bonded or tied together, or having to manually specify contact pairs, we don't have to do that. All we do is we specify a general contact. We tell it what the coefficient of friction we want to use is in a contact property, and the solver knows that unless I've manually tied faces together or specified that they need to be bonded, that any face in or out of contact, as it goes through the solution, when they do come into contact, it's a contact pair. So this is a real time saver. Just imagine the number of contact pairs. And it's just would take a lot of time to define the contact pairs for all of these gear teeth. And the same thing for interference. So I've actually run this in two steps. I have an initial interference that takes place. I don't have to manually specify interference faces. I just say, look, just account for any faces that are interfering with one another. It manually goes through and it looks for those faces, and then it knows that in step number one, it just resolves the interference. So if we take a look at the results, you can see I've got two steps. The initial one is the interference step. And these are nonlinear runs, so you get incremental results. And you can see that even just resolving the interference, so let me animate this. You guys can see it's resolving the interference. I just want to do the interference, so not the rotation. But so you can see it resolves the interference first. And what's interesting is you actually have some plastic strain just as a result of resolving the interference. So even before you start rotating this gear, you're starting to get some plastic strain. I think I used an aluminum material here that had some post-yield behavior defined. So we can initially resolve the interference, and then we can go ahead and rotate this. And if we're interested, like I mentioned earlier, we kind of wanted to get the torque requirements. You can actually create XY plots that we'll take a look at the history data. So basically the torque versus rotation applied. I think I rotated the bottom gear here, and I think I've already got a curve that shows that. So I think this guy rotated twice, so 720 degrees. So one of these is probably the first rotation, and then the other one is the second rotation. So you can get a feel for exactly how much torque is required to drive that rotation. So again, I like this example because it's one of those ones when you first look at, especially as an analyst, you're like, oh, okay, this doesn't appear to be that difficult, what you're trying to solve. It's practical. But when you start getting into the weeds, right, it's a pretty complicated model. So let me show you guys another example that uses Structural Performance Engineer. So this is an example of kind of a hyperelastic, meant to kind of mimic a honeycomb structure. And what we're doing here is we're fixing the outside. We're using a hyperelastic material. And in the center here is a device that can rotate or move the center kind of up, down, left, or right. So again, if you were running this in Solidworks, and depending on the level of displacement, or a lot of other traditional FEA tools, right? You would have to know which faces are going to come in contact with each other. So let me pause this and show you guys contact pressures. Kind of move towards the end of the simulation here. So you can see we're starting to get contact pressures here. So that means these faces are touching one another. How would you know what faces were going to come into contact if you were running this in SolidWorks, right? It's very model dependent, it's material dependent, it depends on the level of rotation and displacement that you're applying to this model. Not having the specified contact pairs is a huge time saver for these types of analyses, right? For problems where you've got ill-conditioned contact, this is a pretty big game changer. And let me show you guys another real benefit of using this, right? And we've heard this for a long time that having a brick mesher can be a real value and time saver, especially when you're running nonlinear analysis. So you can see I'm using a swept brick mesh. I also think that I'm using a hyperelastic material here, so I'm also using, I believe, H elements. So there are different kind of element formulations that are available. And if you've got hyperelastic materials, there's an H element that I think it adds an additional pressure degree of freedom to the center of the element, but don't hold me on that. Hold me accountable to that one. I know. So these elements are basically written to handle hyperelastic materials. So, and if we actually take a look at the material that's being used, I think this is one that we actually curve fit. So let me just check the materials that are in session. And I'll show you, I'll play a little video that kind of describes the material calibration capabilities. Yeah, so this is using a hyperelastic material, and we can see the behavior. I think it's a Mooney Rivlin, but yeah, so you guys can see the material constants. And again, it gets those, so in this case, it actually fit some test data in order to get these material constants. And the feedback that you get when you're fitting test data is really, really cool. So, since we're on the topic of hyperelastics here, let me just pop back into the presentation, and I want to show you guys. So there's a material, like I mentioned, there's a material calibration app that basically allows you to take test data that you've got, and the test data can, be multiple. It could be captured using different means, right? So whether it's uniaxial, biaxial, planar tension, so you can fit the curve. You can enter in your test data. You import it. You can fit it to different material models, so you can kind of run through all of the different material models that are available for hyperelastic and get a feel for how accurately those material properties fit your test data. Another nice thing you can do is you can actually look at the stability range. So if you know that you're going to have strains that are above a certain stability range, you can see where the material is unstable, and then try to fit it to a different curve to ensure that your materials are stable throughout the range that you want to use them in. So, all right. So that's that example. Let's take a look at a couple more examples, because I want you guys to get a feel for another few things that you wouldn't have been able to do inside of SolidWorks. So there's the capability to do what's called damage modeling here in structural performance and structural mechanics engineer. And what damage modeling basically is an additional material property, and it kind of defines what happens when you start getting the material starts to neck, and it basically can hold less and less load until it can hold no more load. You'll hear it called like element birth death, element deactivation. So in this case, we're actually running a Sharpie impact example, and the damage model for our bar here, which I think is an aluminum bar, has been set. So you can see as we continue to increase the load by pushing down the kind of that top plunger, that we'll start to see some elements go away. So if you have a notch in a model and you want to, this would require a really fine mesh, but you could kind of use it to mimic or approximate crack propagation, provided you had a really fine mesh. So we can see those elements being turned off and the crack kind of propagating through the material, right? So again, this is a type of analysis. You just wouldn't have been able to do this with SolidWorks Desktop, right? So I like showing these. Obviously, you can do a lot of the same things, the types of analyses that you could do in SolidWorks, but these are things that, either would have been really time consuming, like the gear and that honeycomb structure, or just impossible to do with the desktop solution. Yeah, so we can see that crack propagating. Again, using a nice, well-structured brick mesh to handle this. So let's go back to the bottle example. So I think I mentioned, right, they wanted their this beverage company that we're working with wanted their industrial designers to be able to run a handful of simulations. And two of them were, well, one of them was a crush test. So they wanted to take their bottle, and basically crush it. So this is using the Abaqus Explicit solver. So this is structural mechanics engineer, kind of the highest end available in Simula on the structure side. Again, look at all the self-contact that's going on here. I don't have to specify any contact pairs, right? I let the general contact take over. In this particular scenario, I'm actually utilizing shell elements. So there's a pretty cool feature manager here. I don't want to get into the weeds for a lot of this stuff, because I think if you guys are interested, it's an opportunity for you to either engage with us or engage with your reseller to get a little bit more information. So I'm just kind of hitting on some of the highlights, but in this model, I'm modeling the bottle as a shell. So, and I'm using a PET plastic, but I don't have to specify the shell thickness. So if you've got a material, kind of a shell model, so a thin-walled device or structure, and you want to model that with shell elements, so you're modeling it with a 2D element and then kind of accounting for the thickness via the shell definition. You don't have to manually specify a thickness. It can come from a solid. It can be manually specified. I think it can even do cloud data. I think one of my colleagues was telling me recently, if you've got kind of cloud data for the thickness of a part, that you can read that also. But I'm basically just saying, look, I want you to read the thickness from the solid that was imported. And in this case, I'm just using a coupling to drive down that top face. And like I said, in this example, I'm using the explicit solver. So it's a really, really, let me go back to results. It's a really powerful solver that's available in Structural Mechanics Engineer. Runs super fast if you're using the cloud, particularly if you've got, you can purchase cloud credits that allow you to run on the cloud. It runs really, really fast. So we can even take a look. Let's see how long this guy took to run. I think I can access that data here. So if you guys are familiar with Abaqus, you'll notice that, when we hit solve here, what it's doing is it's writing an Abaqus input deck. And, this is, if you were running Abaqus CAE, this is kind of what you would have seen as you were running it. So wall clock, 2,400 seconds. So somebody who's good with math, 24 divided by 60, 240 divided by 60, what is that? Is it 40 minutes? Yeah, it's about 40 minutes to run this. So again, man, you guys take a look at what that looks like. It was you couldn't, if you tried to set this up and run it with an implicit solver, you would have a really, really, really hard time getting this to solve if you could, and it certainly would not solve in 40 minutes. And I'll show you guys what the mesh looks like. I know we didn't show it, but you guys can see it's a pretty well-defined, not overly fine, but it's a pretty well-defined mesh for this example. So then they said to us, look, there are often times where our bottle is filled with liquid. Is there any way that you can account for that when you're running an analysis? So one of the techniques that has been turned on in Simula is the ability to model what are called SPH elements, or an SPH scenario. And that stands for smooth particle hydrodynamics. So what I did is basically the exact same model. I made a couple changes just because I wanted to show them when we were demoing that, I think in the previous example, I said that the top and bottom were modeled as rigid structures. In this case, I think I modeled them as shells. But what we've done here is we basically added a volume inside the bottle and said that those are going to be modeled as SPH elements. So that allows you to account for like sloshing behavior. You could even take into account like the heating of those elements if that's going to apply a pressure, like an external or a pressure force on the inside of the bottle. And in addition to that, you can actually see as the fluid starts to come out of the bottle when this thing is being crushed. So SPH elements are some real eye candy here, but it can also be used for some other cases, right? So I have my colleague Michael Steves actually did this to model a bird strike. So let me show you what that looks like. Or let's take a look at some of the other types of analyses that you could do here using the Simula tool. So we didn't talk about drop testing. Obviously, drop testing is a nice place where you can utilize explicit dynamics. Clipping, sometimes clipping applications can be a bit tricky for implicit solvers because you kind of have a bistability point, right? You have the point where the clip is kind of riding along, and then at some point it needs to kind of snap over something or snap across something. And at that point, you've got numerically, it can kind of be tricky. So there are some approaches you can use to kind of account for energy and kind of try to damp it out. But in general, solving this with like an implicit or a static run can be really, really difficult. So you need to start accounting for the inertial effect. So this is a couple examples of explicit dynamics. If you guys are using the desktop products to do random vibration or any linear dynamics, we've heard in the past that sometimes post-processing can be a bit of a pain. So as the models get larger, you don't have that concern when you're using the Simula and the Simula tools. The way they handle data is really, really revolutionary. So if that's something that you're concerned in, I hesitate to suggest using these Simula tools for linear dynamics because on the desktop, if you're using Solidworks, you have a really, really good solution. But if there are situations where your data is becoming hard to manage, or the models are just really, really large because you can take advantage of cloud computing using Simula, that's a place where you can definitely leverage the Simula tools. Complex frequency vibration, you may have heard of this. It's typical. The most common place this is used is for brake squeal. So if you want to know when the brakes in your car are going to start squealing, that's kind of an example of complex vibration. We showed you this. This guy is a bit of a lot to look at, but these are some of the examples of simulations that we've been running, in the last month or a couple months. No, let's say 6 months. I shouldn't say a month because some of these are a little bit old or a little bit older. But these are some of the analyses that you can now run using the Simula tool. So this is the example I was talking about earlier that my colleague Michael Steves did. It's using SPH elements to model a bird strike. I know it's a little bit gruesome, but it happens. So you can see exactly what happens to the bird, which it's not going to be a good day for that bird, and also what happens to the wing. I don't know how much he scaled the deformation. It's hard for me to believe that would cause that much deformation, but we can also do blow molding. We showed you this guy, the bottle crush. This is another example of doing damage analysis. So if the blade strikes a rigid body, what's going to happen to the blades, right? So we're using that element deactivation when it exceeds a certain stress. Door impacts, bottles dropping, riveting operations. Another, here's another example, right? If you were trying to solve this wire crimping in SolidWorks, how would you do that? How would you do that? I mean, how would you know what faces were going to come into contact with one another from those wires, right? So another really, really powerful analysis. Yeah, so this an example of a lot of contact going on as well as buckling. That honeycomb I should have highlighted a little bit more, but there are actually some localized buckling that took place as that thing was being rotated and crushed. So what's coming next, right? We talked about structural analysis. There's another role called structural engineer. I would argue that it's just so let me give you a little bit of a breakdown. Structural designer basically only does solid elements, and you saw the mesher, right? There's not a huge amount of mesh controls. Structural engineer is still linear analysis, but it adds a full host of like meshing capabilities. So you can do shell elements, which you can't do on structural designer. You can do beams and springs, and you just have more mesh control. So I would argue that honestly, structural designer can do most of what structural engineer can do, with the exception of like shell elements and beams and springs. And if you need more than that, I would say the next path would be to go to structural performance engineer, and then structural mechanics engineer if you want to do dynamics. So again, like I said early on, it's an exciting time to be a SolidWorks user. It's an exciting time to be an analyst like me, because we are going to be collaborating more and more with Simula. It only makes sense to give SolidWorks users, the largest CAD community, the most passionate CAD users in the world, more and more functionality. So what we've done is there are two more roles. If you're interested in them, we can talk about them right now. We're not focusing on them. There's going to be a big push about the fluid dynamics role here in Q4. And then in Q1 of next year, we're going to talk a lot more about plastic injection engineer. You're also going to start to see some more stuff related to generative design, topology optimization, because we realize that's the future. That additive manufacturing piece is something that we want to focus on. So there are two roles available for fluid dynamics and plastic injection molding. They have the same feel as those SimuliaWorks tools. You import or use the PLM strategy to get your SolidWorks model in, and then you have some guided workflows that kind of allow you to run these types of analyses. Actually, yesterday was the first day I got a model from a customer that's interested in the plastic injection engineer role, was able to, with the help of some of my Simulia colleagues, get them some results within a couple hours. So man, it's just a really, really exciting time to be, working at this zone. We're so happy the SolidWorks community to be working a lot more closely with Simulia. And, I didn't highlight a lot of the stuff that you can do on the platform. Let me show you guys a couple things, right? So if you haven't utilized the 3D Experience platform, it's really a collaborative tool. So, if you want to use it to like manage projects, to share data, in this quarantined COVID world right now, a lot of us are not able to go into the office. I'm working from home here in San Diego. So having a tool that you can access from anywhere is kind of vital, right? So the 3D Experience platform, you can access it from anywhere. I've got access to the results for all of the simulations that I've run. So, I can come in here, I can look for my content. I can say that physics simulation is kind of that's when you've got some analysis. And I can highlight any one of these. So this is actually the plastic injection run that I ran yesterday. I can say that I want to preview it. Oh, that must not be the right one. Let me pull up a different one. So this is a click gear that I ran the other day. That's interesting. As soon as I say that, right, there's an issue. I apologize for that, guys. So let me just try one more time. We should be able to preview this stuff. Let me open it with 3D Play, which allows us to kind of quickly preview. Oh wow, so that must not be the right part. Sorry, maybe I hit physics. try this one more time. Physics simulation. Let me just sort it by date real quick. I just did this a second ago before I hopped on, so I know that it works. Ah, there we go. Interesting. It's still telling me that I don't have valid content. Well, this is obviously user error, which, as I mentioned, it's possible that it's my fault. But you guys, you can see, right? You've got access to all of the different analyses that you've run. So you can see the drop test. I've done some tire rolling analysis, which is a lot of fun for a prospect. We've done a lot of crash testing for different companies, blow molding, insertion. And yeah, so it's a really, really powerful tool set. And, it's very easy to share these results with other people that are inside of your organization using the collaborative aspects of the platform. So I'm going to switch to the left here and see if there are any questions that I can answer. But yeah, so I kind of plan to have about 15 minutes here at the end to be able to answer questions. So if you guys have any pressing questions, you just want to add them into the chat, I will do my best to answer those questions in conjunction with trying to figure out on the fly, why I can't preview some of this stuff. So someone's saying he was able to use the platform. Yeah, it is. It's actually, I think, and again, to our detriment, SolidWorks internally as well as externally, we're very passionate about SolidWorks. So I think there was a bit of hesitation with our adoption of the platform. It's our own fault because, especially for analysts, man, the stuff that we can do now that we're on the platform and being able to collaborate with Simula is just extremely powerful. So, maybe we were a little bit late to adopt, but I feel like we're really coming along now. And if you guys haven't heard, there are some really great offerings now for SolidWorks on the platform. So there's like 3D Experience SolidWorks offerings that allow you to utilize some of the CAD products that we've developed to run on the cloud. And they are extremely powerful. They're great. They're great tools. They really have that SolidWorks flair and that feel. Very, very easy to use. There's XDesign, there's XShape. So yeah, check those out. They're offerings that are available, I think, since the beginning of the month. So some great tools. Like I said, you're going to see more and more stuff coming from these collaborations. The 3D Experience Works portfolio is not just Simula Works. There's Delmia Works. There's it's basically the opportunity for SolidWorks to start collaborating with all of these other amazing brands that Dassault has. So, like I said, I think we kind of lived in our SolidWorks hole for long enough, and now it's time to kind of expand and start to leverage all these other powerful things that Dassault and the platform can offer us. Circuit board drop testing, yes. My colleague Andrew Bonica noticed that. I am working on that with Ramesh. We are going to be doing a high-tech focus group of examples. So yeah, we're going to be doing that. I really kind of want to add the interface material and kind of model the bonds failing between the components and the board, so the epoxy. But we'll see if I can do that. How to separate point load or uniaxial forces and how to define forces like G-force. All of that stuff you can do via setting up couplings and extracting the directions of the forces. All right, guys, if there are any other questions, feel free to ask. Otherwise, I think I'm going to give you guys 10 minutes back of your day. So. All right, well, I will bring up one last thing because I know I'm an engineer too, and there are often times when I don't feel like asking questions in public. This is kind of just an overview of the capabilities that are available in Structural Performance Engineer and Structural Mechanics Engineer. But I did want to point out, this is my email address. If you guys have questions or you want more information, I feel free to email me. I will be as honest as I can about the capabilities and what we can do. I don't mind answering emails. It's what we're here for. I'm happy to support the SolidWorks community. I love working with you guys. It's really invigorating working with a community that is so passionate about these products. And anything I can do to help, feel free to reach out. And stay tuned for more and more coming from the SimuliaWorks the SimuliaWorks collaboration. All right, and that being said, I think that I am going to hop off. So everybody have a nice Friday. Stay safe. It's a weird world out there nowadays. So wear your masks if that's what you want to do, and try to stay safe so we can get back to normal as quickly as possible. Cheers, everybody.